So part 3, now we're going to figure out how to marry the boundary to the bulk. So we're gonna consider a map from the boundary to the bulk here, where these are our panels, and remember we have 6 of them. But here's one of them, and here's a map. So this, essentially, these curves of type change, bolded, essentially a map onto the bulk and onto the MathCal I, which we defined in the previous video. And we can also think about pulling this back via the inverse mapping. To the boundary, we recover our 6 charts. So these are sort of like charts here. Now, the curves of type change on the boundary map onto gamma, right? So this is sort of like a piece of gamma, if you can see. So that would be 1, 2, 3, 4. 1, 2, 3, 4. It'd be like 4 edges out of the totality of gamma, which is 12 edges. The octahedral graph. So this is like a piece of that graph. Moreover, the points at the center of each panel, so the R, map directly to gamma as special points. Soon we will understand gamma to be a light-like set. But first, let us configure our signatures on each of the 6 panels in a more conceptual way. We place 3++ signatures such that they share a common vertex on the cube. We do the same for the corresponding antidiagonal vertex. So say we have done this for P and Q, then immediately we see that these 6 charts cover our original surface we found in part 1. Repeating this process, we obtain 4 cone manifolds which perfectly match up with MathCal I. In other words, we obtain plus plus, minus minus, minus plus, and plus minus signature cone manifolds.